We have an important set of topics today. We're going to look at more inheritance issues and then talk about how classes that utilize inheritance can work together. So this first part, we're going to talk about something called abstract methods and interfaces. And just to kind of remind you where we're at from last time, we can have a class called a superclass that defines some base functionality, and then a subclass, or really multiple subclasses, can inherit from that superclass, and each provides some more specialized behavior. The syntax for this uses the extends keyword. So you say that like a student extends a person class, and in the constructor you have to build up that super part of the object, and you either do that through an explicit super constructor call that matches up with a constructor that's available in the superclass, or if you don't say it and there is a default constructor available, that's what gets called. Then you can override methods. So if you have a method in the superclass with the same name and parameters and return type as the method in the subclass, then the subclass can have a new implementation that works for the subclass and has some new or specialized behavior. And there's this @override notation we use to sort of show that that's going on. And if you want to get to the superclass code method from the subclass, you can use the super dot notation, kind of like this dot, that says, hey, don't use my version of this method, use the one that's up there in the superclass. Okay, so that's really all there is to inheritance, but there are other situations that call for more specific other techniques, and so let's look at those. So let's say we have a bunch of shapes, circles, rectangles, triangles, and squares, and we want to implement them. So I'm going to just write some code here to, okay, so I have a public class circle, and you know, what is a circle? Well, basically it is a radius, and you know, maybe it have a center point or something like that, but you know, we're not going to worry about that. And then I need to construct my circle, and I'm going to pass in an initial radius, and I'm going to set the instance variable equal to that initial radius. And again, constructors tend to be a little bit boring. They're just like, here's all the values we need to set, and go ahead and set them. Now, what kind of things are we interested in a circle being able to do? Well, maybe we want to know about the circle, or we could have, you know, our standard get radius, set radius kind of stuff. I'm going to have a slightly different method I want to add for it. So I'm going to have a method that area. So we're going to ask the circle what its area is, and all I have to do here is return. Let's see, math.py times radius, and I could have done math.pow raised to the second power there if I wanted to, but the square is just the two multiplied together. So that says, hey, circle, you know, pi r squared, here's the area, and maybe just to make this a full featured thing, we're going to have a perimeter, and the perimeter is 2 times pi times the radius. And this needs a return type. I was concentrating on not using static there, so I sort of dropped everything. Okay, so that's, you know, not everything a circle can do. Certainly, you know, you can think of a million other methods, but maybe that's of interest. Oh, and actually, let's do a toString for it. Okay, so public to returns a string to string, and this returns area call plus perimeter parameter call. And that's really all we care about knowing for a circle. We still have all our brackets and stuff. Okay, that's good. Okay, so circle, it stores something, we create it, and then we ask it. Again, I'm not passing in information. I'm not passing a radius into this area thing. I'm using the radius that's stored in any instance of a circle. So here in shape test, I can make a circle. Circle C1 equals new circle. I'm going to use a radius of 1 just so hopefully the math I can figure out in my head. And I'm going to print out that circle. And since it has a toString, it should print something out. Okay, so maybe some formatting would be useful there, but anyway, the area is 1 squared times pi, so there's pi, and then the perimeter is 2 times pi. So that looks good. Now let's do the same thing for a rectangle. Okay, so in a rectangle, we might have a double width and a double height. And we need a constructor. Rectangle, double init width, double init height. Do I have, what else do I need here? Come on, show me some stuff. Okay. And we're going to set width equal to the init width and the height equal to the init height. And it has its own area. And we're going to return width times height. And it also has a perimeter. And I do not have my return type. That's why I was, okay, public double perimeter. You know, to be honest, I think it'd be better to call these get perimeter, get area instead of just area and perimeter. And here we're going to return, well, let's do 2 times width plus 2 times height. And I want a toString. And to be honest, even though, you know, there's different things I could print on the toString, but it's actually the same as the circle one. I want to know the area and the perimeter, right? So let's make a rectangle. Rectangle R1 equals new rectangle, and we'll make it 2 by 1. And I'm going to print out R1. And when I run it, the area is 2, perimeter is 6, 2 plus 2 plus 1 plus 1. Okay, so that's all good. Now the thing is, I want you to start noticing that there's some relationships between these circles and rectangles, and really other shapes as well, right? Like triangle would have an area and a perimeter. And also in particular, if I just care about their area and perimeter as a toString, I have this exact same toString thing here in both circle and rectangle and triangle and square and so on. And so maybe there's some structure we can impose on these different classes instead of just making a million different classes. I want to show how they're related to each other and use Java to express that relationship instead of just having a bunch of code that I have to maintain in my head, like, oh, if I change this, I better change in all these classes and keep them consistent, right? So you could sort of imagine there being, you know, the problem is like a rectangle is not a kind of circle, a circle is not a kind of rectangle. So those are not appropriate like super and subclasses of each other. There, you know, you can imagine there's something like a shape, a more generic thing, a more abstract thing that you want to say, here's what a shape is. A shape is something that has an area and a perimeter and a toString, and then these things all inherit from that. And in fact, we might have square inherit from rectangle instead of from shape directly, as it's some sort of specialization of a rectangle. Okay, so if I want to build this, what would this do, right? I might build a shape class, and I want everybody to have an area and perimeter. So I want them to all override these methods here. So let's go ahead and start building this. Okay, so I need to add a new shape class, and that's all I want for it. And in here, I know I want some kind of thing that's like, I want everybody to have an area and override it. And I know I want there to be the perimeter. And I want everybody to override it. And I want a toString as well. And in fact, since it's the same toString for everybody, I can provide it here in shape, and then everyone just inherits it. They don't have to specialize it or anything like that. The problem is, what is the meaning of area for a shape and a perimeter for a shape? We don't know. And so the problem is that, okay, let's go to circle. If I delete the toString in circle, I'm not overriding it from shape. I'm using the one that comes from shape, right? I didn't have to replicate that code. So that's a win there. That's nice. But I want all things that are shapes to have an override of this area and of the perimeter, because I want shapes to provide that information. So a rectangle is going to have that override as well, and override this as well. And I'm going to get rid of the toString. And actually, the main thing I forgot is I'm going to have to say rectangle extends shape. In other words, I'm inheriting from shape. And I want that toString method that comes from shape. And circle needs the same thing. I need to inherit from this. Okay, so we're sort of confused. We got ourselves all confused here a little bit in the sense that I want this hierarchy because it expresses the relationship between these classes well. They are all kind of a shape, and they all want to use the toString that comes from shape. But I've kind of put myself in a bind here that all of a sudden, a shape has an area and perimeter. In fact, I want to be able to call it. What should it be for a shape? Okay, so the key here is that we're going to say, we're going to declare in shape these methods to be abstract. In other words, they do not have an implementation. They do not have the code to it. It just says this method exists. And it is the responsibility of a class that inherits from one of these to actually provide an implementation for it. All right, so the way we do that is we use this abstract keyword, abstract, and then we just end it with a semicolon here. We don't have an implementation. Okay, and we're going to do the same thing for this. So what does this mean? It means that everyone that inherits from shape is going to need to implement these methods because they're part of this contract we're building up, this interface we're saying that all shapes have. And since something inherits from shape, it is a kind of a shape. And it's the job of the subclass, circle and rectangle, to actually implement those. Now, here it's complaining because as soon as you have an abstract method here, then you also have to declare the class abstract. And an abstract class can't have an object of the shape type. In other words, in shape test, if I tried to make a shape S1 equals a new shape, it's going to complain and say cannot instantiate the type shape. And the reason is because it doesn't have a specific meaning. It is something that is an idea, right? We're saying that shapes have areas and perimeters, but there is nothing that is a shape. You can't just say, make me a shape. You have to say, make me a rectangle or a circle or a triangle or something like that. So what is the point of making this shape class? Well, it says we are going to define a relationship between things that are shapes. They're going to have an area, they're going to have a perimeter, and these classes that inherit from them, circle and rectangle, have to produce those. So let's comment this out. Okay, so it's going to say up here, it's going to complain about my class definition. It's going to say the type circle must implement the inherited abstract method shape area. Okay, so again, the point of this is that someone, the designer, the architect of this system, says there are a bunch of related things. Circle, triangle, rectangle, square are all a type of some sort of shape. And we're going to use inheritance to express that they're a kind of shape idea. Now, why express that? Well, you're going to also express that any shape must be able to compute an area and perimeter. Okay? And so, but again, shape itself doesn't know how to compute it because it doesn't know what it is. It's just an abstract idea. Once I inherit from shape, then I am forced to implement these things. All right? But it's nice. It means they all work together. Like you can say, hey, circle, tell me your area, and rectangle, tell me your area. The other thing it allows is that there is code up here that is shared by all those classes that inherit from shape. And the question is, what gets called here? Well, it's the method that actually is part of the object itself. So when circle inherits the toString, it is the circle area that is called here. When rectangle inherits the toString, it is the rectangle area that is called here. All right, so by having the same name here, but different implementations of it, there's common code that works for all the classes, but they all have to implement area for this to be able to work. And so Java is very careful about this and forces you to implement it. If you inherit from this abstract class, you have to implement these two things. Okay, so shape test. You can't have that. Okay, so now let's run this and see if it works. Okay, so we get these two different results, one for the circle, one for the rectangle. We make a new circle. We call print line on the circle. It calls the shape toString because that's what gets inherited by circle. And inside the shape toString, it calls the area belonging to the object, the circle, or the rectangle. All right. So, but notice these all can then work together in a very common way, and it's very nice, really. You know what to expect when you inherit from this abstract shape class, that they will be able to do these certain things: compute an area, compute a perimeter, and print themselves showing the area and perimeter. And they're tightly connected to each other. But again, there's no toString in circle, no toString in rectangle. They inherit it from the shape class. Okay, so there is a further expression of this idea called an interface. And an interface, here we have an abstract class that has two abstract methods and one that's implemented. An interface has all abstract methods. And so it is a class that is just a bunch of methods. You can't have an object of that interface class, just like you can't have an object of a abstract class. It can't have any instance variables because there's no object to ever be made of it. An abstract class can have instance variables that get inherited by the subclasses. And so basically an interface is just something that says, hey, I want you to participate in this larger ecosystem of classes that we're defining, and we're going to say that if you use this interface, then you're going to implement a certain method. So let's make a new interface. Okay, so I need to add it. New interface, and I'm going to call this drawable, and that's it. Okay, so now notice it says instead of class here, it uses the word interface. I'm going to make a method in this interface, draw, and any class that uses this or what's called implements this interface has to also actually implement this draw method. All right, so how does this work? So I could have multiple things in here, draw, erase, whatever, and then you have to implement all those things. Okay, so let's go to circle again, and circle extends shape, and it also implements drawable. Okay, so notice this is getting kind of complicated. You are in Java, you are allowed to extend from one superclass, and you can implement from multiple interfaces, each separated by a comma. Here it's complaining again, and it's saying the type circle must implement the inherited abstract method draw. All right, so I need to do that. I'm going to add this unimplemented method, so it's going to provide the structure for me. And here's this draw. Okay, so what is this? If this was a graphics thing, I would have to be able to draw it, but we got text here. I'm going to print line. I'll do a capital O for a circle. Okay, that's the draw for a circle that I'm going to do. Okay. And then if I look at a rectangle, I can also implement drawable. Man, I don't know why I can't get that order in right. Drawable. It's going to complain about needing to implement a draw method. I'm normally a little suspicious of these quick fixes, but in this case, it's not a bad thing. And here I'm going to how am I going to draw a box? I'm sure there's some nice special character I can draw. Oops. There. There's my rectangle. Those are terrible draw methods for both the circle and the rectangle. Now in my shape test, if I call draw on it, let's just r1.draw, it draws it, which is to be expected. Now the thing is, notice that both rectangle and circle implement drawable. I can actually implement drawable up here, and let me get rid of it on the subclasses. So basically I'm saying any shape, every shape has to implement drawable. And these classes, because they extend shape, inherit that requirement from drawable. Now you might wonder, here we implement drawable, and I don't have a draw method in the class here. And it's okay because you can't make an object of the shape class, and so there's no way that it could ever have to draw something itself. So it knows that we're inheriting this requirement, and it gets passed on to rectangle and circle, and they have to implement it, right? So if I comment this out, it's going to complain and say the type circle must implement the inherited abstract method draw drawable. Draw. So I have to implement it. Okay, so again, what is the point of all this? The point is to add requirements to your code and force them to all have some sort of common interface, some kind of common public methods that people can count on having. And the way you do that is you either inherit from shape, and so you know that it has to have, because it's an abstract class that has a area and perimeter and a toString, that you're going to have to provide implementations for the area and perimeter, and you're going to use the toString. And then since shape implements this interface, and again, an interface is really just a abstract class that has only abstract methods. Notice I didn't have to say here public abstract void draw, because as soon as it's an interface, we know those are going to be public abstract, right? So you shorten it down here. You can't have it private because there's no object that can take advantage of that private thing. You can't access it. There's no code that can access that private thing. And we know it has to be abstract because that's what an interface is. They're all abstract. Okay, so to be honest, this is a lot of stuff, but it really is how you start building up larger type systems. You define either abstract classes that have requirements for things that all common type things should share in, or you have interfaces that say, hey, if you want to participate in this thing that, we can count on you being able to draw something, then this is what you're going to do. You're going to implement this interface. And then the hard thing again also is that you're now keeping track of sort of multiple levels, multiple files at the same time. You're like, okay, this thing does this stuff, and then when I'm writing it down here, you have to remember which are the things that you have to provide. And luckily, again, Eclipse provides some hints to tell you what's going on there. Okay, so the next step is going to be using these collections of these connected things in a little more uniform way. So we'll get to that.